Welcome back to The Explainer, presented by Forge College. Today, we're unrolling the blueprints. In our last session on financial and payments use cases, we tracked some pretty simple financial payments, right? Just moving numbers from ledger A to ledger B. But today? Well, today, we're grabbing our orange and green ink to map out the wonderfully messy, absolutely fascinating world of real-world data. We're talking supply chains, digital identity, and healthcare.
Okay, let's dive into this. Here is our blueprint for today. We'll start with Beyond Finance, look at core concepts, jump into logistics tracking, digital identity, healthcare records, and finally wrap up with building proofs. Let's get to it.
Section 1. Beyond Finance. New rules.
You know, when you move funds, it's pretty much binary. The parties involved really just need to know the payment is final so they can balance their books, and that's it. Simple. But what if you're tracking a massive shipping container full of bananas across the ocean? Now that introduces some real-world messy constraints. Suddenly you've got strict privacy laws, nosy competitors sniffing around, and a whole lot of regulatory red tape. You have to prove who did what, but absolutely without exposing all your trade secrets to the entire internet. It is a massive balancing act.
All right, moving right along to Section 2. Core Concepts, State and Provenance.
Before we actually look at specific industry schematics, let's lay out our core tools on the drafting table. First up is state replication. Put simply, this just means everyone is looking at the exact same master copy of the facts. Think about it. If we're all staring at the exact same authoritative ledger, we literally can't argue about what just happened. It mathematically kills disagreement right out of the gate.
But the question is, how fast do we actually agree? We've got eventual consistency, which is kind of like a physical delivery truck losing cell service for an hour. You know the system will eventually catch up and the world definitely isn't going to end. But on the flip side, you have linearizability. This is a strict, immediate global order. You absolutely need this for something like a clinical legal timeline, where knowing the exact millisecond a patient's chart was updated could literally be the difference between a saved life and a massive lawsuit.
Next up on our list is provenance. So provenance is basically the technical record that proves exactly how the state changed. Who did it? When did they do it? Mechanically. We pull this off using cryptographic hashes. Honestly, just think of them as unbreakable digital wax seals. It creates this airtight mathematical chain of custody that proves, without a doubt, the history of the data hasn't been tampered with. And this brings us to the fundamental balancing act of the whole system: on-chain proofs versus off-chain privacy. Look, if you put massive, highly sensitive documents directly onto a shared ledger, you're looking at terrible privacy and outrageous storage costs. So what's the clever engineering workaround? We put the compact, unalterable cryptographic proofs directly on the ledger while keeping those bulky or highly sensitive payload documents safely tucked away in private, off-chain storage. Best of both worlds.
Section 3. Logistics tracking, real-world workflows. Let's see this in action. As you probably know, supply chain coordination is notoriously messy. We're talking about participants ranging from manufacturers to carriers, all the way to customs agents. To make it work, they rely on a shared append-only event stream to track custody transfers. The brilliant part is that while everyone shares the digital wax seals, those hashes we talked about, to prove the sequence of custody, the actual juicy commercial terms and the PDFs of the bills of lading, those remain totally private and off-chain. Moving to Section 4, Digital Identity, Real-World Workflows. I mean, we've all felt the frustration of handing a bouncer our entire driver's license, right? You're basically showing them your exact home address and birth date just to prove you're over 18. It's a massive oversharing of personal data. But here's where it gets really interesting: selective disclosure. Using this, an issuer publishes a verifiable credential, but they keep the actual claims off-chain. So you can mathematically prove you are over 18 without revealing a single other piece of information. The bouncer gets the rock-solid proof, but there is no way they're getting your home address. It's a total game changer. Let's look at Section 5, Healthcare Records, Real-World Workflows. Now, healthcare arguably has the absolute highest stakes for both data provenance and patient privacy. In this environment, they use tightly restricted replication. They have to perfectly balance the legal necessity for an unalterable audit trail, like knowing exactly which doctor updated a chart and when, with strict patient consent. So the ledger mathematically proves the audit trail, but private, highly secured off-chain servers hold the actual clinical data. Putting these three side by side perfectly illustrates the point. Logistics relies on shared streams to keep things moving. Identity thrives on selective disclosure for privacy, and healthcare demands strict, restricted read access.
It's the exact same underlying technology, just sketched out completely differently to fit entirely different privacy constraints along the transparency-privacy spectrum.
Which brings us to Section 6, Building Proofs, Mechanics, and Next Steps. Time to roll up our sleeves. Let's actually jump into the technical workshop and look at the code logic. Step 1 is deterministic serialization. Honestly, that's just a wildly fancy way of saying formatting the data the exact same way every single time before you hash it. Step 2 is simply applying an algorithm to hash those bytes. Step 3 assembles them into a Merkle root. You can think of a Merkle root as a highly compact digital zip file of truth. And finally, Step 4 is verification, where an auditor can mathematically prove an event was part of that root, all without exposing the actual payload. Pretty cool, right?
So, the crucial point here, if you take away just 3 design principles from today's explainer, make it these. Number 1, always separate evidence from your payload. Put the proof on the ledger, but keep the data itself in a controlled store. Number 2, perfectly match your consistency model to your actual operational needs. And number 3, design your retrieval and verification workflows right up front. Which leaves us with one final, pretty provocative question. If this blueprint so perfectly solves privacy and trust, why isn't literally every enterprise in the world using this right now? Well, there is a massive difference between a clean engineering blueprint and the messy, slow reality of corporate friction. To master these concepts, dive into those upcoming adoption challenges, and explore way more Web3 topics, make sure to visit us at forge.college. Keep building, keep questioning, and I'll catch you in the next explainer.